Welcome to the Joint Intersectoral Analysis Framework, JIAF for short, session on indicators and severity. The JIAF is a multi-partner endeavor that brings together UN agencies, NGOs, and donors. This session is part of a broader training plan for JIAF 1.1. The plan is composed of 3 elements: 4 high-level pre-recorded presentations, 8 more in-depth blended sessions, and workshops and webinars. The first set of presentation is already available. It is composed of 4 high-level pre-recorded presentations that are actually about 15 minutes each. There are 4 presentations, one that gives a broad overview of the concept, methodology, and process, and then 3 other ones that focus more precisely on the concept, the methodology, and the process. The second set of presentations are more in-depth and pre-recorded blended presentations that include introduction to the companion tools, exercises, etc. And I would say that they're probably about 40 minutes each. This presentation is part of the in-depth blended learning sessions and focuses on aggregation and PiN. And now let's start digging on the JIAF. Concretely, the JIAF approach consists of 3 elements. First, a concept. Second, a methodology. And third, a process. The concept is that the analysis is intersectoral as opposed to multisectoral, with affected people as the starting point, and we'll get back to that in the coming slides. The methodology is articulated around 3 elements. First, an analytical framework, then indicators with severity thresholds, and third, an aggregation method for each of the data scenario that your team can face. The aggregation will then lead to the calculation of the number of people in need. Finally, in terms of process, we will see that it is very similar to the H&O process with which you're already very familiar. The aggregation is part of a bigger methodology. First, the analytical framework that gives a structure to how the information about the challenges faced by the population is organized through thresholded indicators and classified by severity, and how these indicators are processed, treated, aggregated, and visualized to help make sense of it. Let's start with the framework. The JIAF is built around 5 pillars. First, the context. Second, the events and the shocks. Third, the impact. Fourth, the humanitarian conditions. And fifth, current and forecasted priority needs concerns. The framework serves to organize information and visualize relationships to bring a structure to the analysis. Now, let's zoom in on the humanitarian conditions pillar. The humanitarian conditions pillar is organized around 3 very interlinked humanitarian consequences. The first one is living standards, the second is coping mechanism, and the third is physical and mental well-being. The global clusters came up with indicators to illustrate the severity of needs for their sector for each one of those humanitarian consequences. Each indicator is thresholded to establish intersectoral PiN. The objective is to have a distribution of the population per severity class. For the entire humanitarian conditions pillar, it is actually not recommended to try to estimate an intersectoral PiN at the sub-pillar level due to the interrelated nature of the sub-pillars. Depending on the scope decided by the JIAF team, the analysis can be done at different level and distributed across the population at units of analysis decided by the team and the crisis level. It is also possible to do it per population group if it has been discussed and if, of course, the data is available. The 123 indicators are compiled into what is called the JIAF indicator reference table that you may have seen. It is a live Google spreadsheet, and the link is available at the end of the presentation. The global cluster coordinators elaborated those indicators, and for each of in the indicators, the information available are the sector, the subsector, which pillar the indicator fits in the JIAF framework, which subpillar, and the name of the indicator. Then you have a data collection technique associated with this indicator, in this case, the household survey, as well as the recommended source and assessment, where it's coming from. Then the global clusters indicated the thresholds and ceilings for each class of severity pertaining to this indicator. These thresholds and ceilings can be adapted to the context. And additionally, some clusters don't have fixed thresholds. And in that case, national clusters should reach out to their global counterparts for further guidance. Once data has been collected to inform the indicators, it is time to aggregate all the information and start looking at estimating the number of people in need. Two scenarios, called Scenario A and Scenario B, have been developed to support the aggregation of indicators. The scenarios are determined based on the availability of JIAF indicator data, in particular whether data is available at household and/or area level. Data Scenario A is easier to implement and allows for a full breakdown of population by severity class, which is unfortunately not possible for Data Scenario B. However, Scenario A shouldn't be pushed, and no data should be discarded. If you have multiple data sources and indicators are unlinked, you must use Scenario B. Furthermore, the sectors can choose to recommend non-MSNA data source, and this should not encourage MSNAs. See the guidance, section 2.2.4, and I quote, "If a specific JIAF household level indicator has multiple sources, for instance, MSNA and sector-specific assessment, the concerned sector should be able to decide which source should be used for that indicator." As mentioned in the previous slides, Scenario A is not superior, and we're not trying to push for the adoption of a Scenario A. As a matter of fact, both scenarios have their own characteristics. And the use of a scenario is actually quite independent from your preference. It depends on the availability of data. So for instance, Scenario A should be used when household level data is available for all selected JIAF indicators and contained in one unique database, and relevant area level information can be easily linked into this database. For Scenario B, however, there are no specific requirements. The data for select JIAF indicator is not contained in one specific household level database, but rather in one or more area level datasets or multiple household level datasets. This means that even if there was an MSNA dataset available, if any other data needs to be included in the analysis, including both area level datasets and other household level datasets, then Scenario B would apply. Now, in terms of outputs, Scenario A allows you to yield a preliminary intersectoral PiN with an initial breakdown of population by severity phase. Scenario B is not as precise. It allows to yield a preliminary intersectoral PiN but in brackets, meaning that you would have a minimum or a maximum estimate, not an absolute number. This initial estimate also provides a severity phase per area, but does not allow a breakdown of population by severity phase. On the right side, both scenarios have pros. Scenario A is easier in terms of aggregation. The steps are easier to implement and allow for more precise initial PiN estimation and a full breakdown of population by severity phase. Also, quite crucial, the linked indicators. It is possible to identify household-facing needs in more than one dimension or indicator at the same time, and to unpack the analysis further to understand which sectors may be driving overall humanitarian needs within a crisis. This added value of scenario A has been very little explored at the moment, and we're quite hopeful that HPC 2022 will demonstrate its use. The pros of scenario B is that it actually allows to use a variety of assessments and information at both household and area level, hence the possibility to triangulate the results. In addition, by incorporating multiple datasets, scenario B leaves more room for incorporation of sectoral expert judgment and analysis, which has a critical role in the JIAF. Now, in terms of downsides, scenario A has 5 main downsides. First, the triangulation is limited because it's difficult to incorporate additional area level information into linked household data set. Secondly, and this is perhaps the most important downside, is that if you're relying only on a single household level assessment, such as an MSNA, then the scenario A aggregation could potentially lead to a weak or limited quant analysis that does not match the reality of the situation. And that would be because the MSNAs often require sectors to only submit a couple of indicators per sector due to operational restrictions, time constraints, capacity on the ground, and limitations when you conduct a household survey in emergency environment. The third downside is that at the same time as a single household level assessment has happened, some sectors might rely on sector-specific assessments to inform their sectoral person in need, their PiN number. And then as such, it means that different data sources could potentially lead to a discrepancy between the intersectoral PiN that would be calculated using the single household assessment / MSNA and the sectoral PiN that would be calculating using the sector-specific assessment. The fourth downside is that household level data collection is actually not suitable for all indicators. An example would be health indicators that are sometimes better collected at the area level. Finally, the fifth downside is that given the current COVID context, data scenario A may not often be possible because household level data collection might not be possible. Scenario B also has downsides, unfortunately, 4 main downsides. The first one is that the aggregation steps are actually more difficult to implement, and they don't allow for a full breakdown of population by severity phase, and expert judgment is needed as a following step. And this is crucial because, and that's downside number 2, without the completion of the expert judgment step comes a risk of underestimating PiN as a result, because they are presented as minimum population in this severity phase or higher, quote unquote. Unfortunately, there is also a lack of clear guidance on expert judgment, which we hope will be solved for JIAF 2.0. The last big downside of scenario B is that the indicators are unlinked, meaning that it's not possible to identify a specific household-facing need in more than one indicator or dimension simultaneously, and so we can't assess the overlap between sectoral needs. So in a nutshell, both scenario A and scenario B have pros and cons. The JIAG has developed different scenarios and pathways to implement those scenarios. So we're now going to jump into the pathway for scenario A. Before you start the aggregation process, step 0 is actually to obtain the household and area level datasets for all indicators included in the country's JIAF. Once you've got the datasets, the first step is to prepare those datasets. We're going to get into the details of what we mean by prepare the household and area level datasets just after this slide. The second step is to reconcile the household and the area level indicators. The third step is to aggregate all the indicators within the humanitarian conditions pillar, and then check if any critical indicator severity score is higher than the final JIAF severity phase classification. From there, you estimate the percentage of households falling under each severity phase and estimate the number of household and people falling under each severity phase. At this point, you have your initial intersectoral PiN, but it's recommended that the final output table also flags any area and groups that are currently receiving assistance so that the current severity phase is understood to be also dependent on current level of assistance. The final step of the aggregation is to review, interpret, and adjust these estimations as part of a joint analysis process. In other words, it is the end of the automated aggregation process, but not the end of the actual analysis. One could say it's actually the beginning. But let's get back to our aggregation methods and let's go straight into step 1. Actually, step 0, sorry. Step 0 is to obtain the household and the area level datasets for all indicators included in your country's JIAF. Here, what you will do is to prepare and clean the datasets. You could use a data cleaning plan that you already have agreed to, or if you don't have any in-country guidelines, you could use something similar to the Quartz Guide to Bad Data. In my opinion, it's a good place to start to have a structure to cleaning your dataset. At this stage, you should also remove any household information leading to identifying the interviewee to ensure proper treatment of data. Final recommendation here is that all the original datasets, once they've been sanitized, should be uploaded on the Humanitarian Data Exchange platform for transparency purposes and to ensure reproducibility of results. Once you've obtained and cleaned/sanitized your datasets, the next step is to prepare them. Each indicator value should be recoded to only represent the severity score. That means either 1, 2, 3, 4, or 5 in both datasets. A common geographical field should be available for each household and area level indicators to facilitate the merging. Strongly encouraged to use P codes and please do get in touch with your IM working group to ensure that you're using the latest, most updated, agreed upon CODs. That is common operational data sets. The next step is to reconcile the household and the area level indicators into one data set. So the way to proceed is to add all the area level indicators to the household level data set. And this results in one gigantic household level aggregation data set, including all data with both household and area level indicators that are linked for each household. Now, since several households might have been interviewed within a single geographical area, the same area level indicator value will be repeated for all the interviewed households in the area, as shown in the example below. In the table below, you can see that for the rightmost column, we have one area level indicator, which is the coverage of DTC3 in under 1-year-old children. And for District A, the coverage of DTC3 is recoded to show severity 1. So that severity 1 will be applied to all the households that were interviewed in District A. So in this kind of a breached table that corresponds to household ID 77 and household ID 78. Now, I just want to show you what it looks like if you use the Scenario A aggregation tool. So this is a screenshot of the aggregation tool, step 2, which is reconcile household and area level indicators. And here you can see the various indicators, with the indicators in yellow showing the magnitude indicators, and therefore the application of that severity for all of District A. And now on to step 3, which is to aggregate all indicators within the humanitarian conditions pillar. The recommended aggregation method is the mean of max 50% of indicators if there are more than 4 indicators, most likely scenario, and simply the mean if there are 4 indicators or less. For each household, the mean of max 50% returns the mean of the area and household indicators that have the highest scores, focusing only on the 50% of indicators that have the highest scores. After exploring aggregation methods, it was concluded that arithmetic and geometric mean, median, weighted sums, etc. suffer from a central tendency, meaning that overall severity scores are pulled down the more indicators are included. So in reality, a household may even have very severe needs outcomes on some indicators, but will not be identified as severely in need if it happens to have a low severity scores on some indicators. The probability of this happening increases with the number of indicators that are available. So we found that this can be avoided by applying the mean or median using only the most severe indicators in each household. As long as an absolute scale has been used for all indicators, this should give an accurate estimation of the overall severity faced by the household. So for further information about the methodology, the aggregation method research, etc., I'll put the reference document at the end of this section on Scenario A. You'll notice here in the example in the table that the JIAF severity phase is rounded up. For instance, if you look at the last line for household ID 79, we have 4 indicators for which the severities are 2, 4, 2, 5. Since I only have 4 indicators, I'm going to take the mean of those 4, which is 3.25. But 3.25 is not a phase. The phase is phase 3. So everything that would fall between 3.01 and 3.99 would fall into phase 3. Now looking at the same step, which is aggregate severity scores for all indicators for each household, but with a more reality looking table. I've added the next few columns to the screenshot that we saw a bit earlier, and that focuses on step 3. So you can see the 6 thirst indicators in blue that correspond to actually the 50% highest indicators of the 13 indicators of the table. So here we had 13 indicators. We're taking the 6 highest one, and the column in black completely on the right hand of your screen is the mean of max 50% of the indicators yield for the severity phase. Let's take an example here. So line 2, we have severity 1, 2, 1, 1, 1, 2, 2, 1, 2, 1, 1, 1. Okay, so we have 13 values. We take the 6 highest ones, which are the ones that now in the right hand side, and that are 2, 2, 2, 2, and then 1, 1. So if we take the mean of those indicators, we arrive at a severity phase overall of 2. Now that you've got a severity phase for each household, the next step is to check if any critical indicator severity score is higher than the JIAF severity phase classification. And if so, to replace the humanitarian condition score with the critical indicator 1. So for instance, for household ID 77 in District A, which belong to the IDP group, the calculated JIAF severity phase is 3. Now, one critical indicator that was identified by the JIAF team previously in the process is safe and healthy housing enclosure unit. And for that indicator, the household 77's severity is actually 4. So what you do next is to override the calculated JIAF severity phase, which is 3, with the critical indicator phase, which is 4, and you enter that into that information into a new column, which you can see on the right-hand side, which is the updated JIAF severity phase, now a 4. The override is explained more in detail in the session dedicated to indicators and severity. But for the purpose of this presentation, just know that critical indicators were identified earlier in the JIAF process, more specifically in section 2.1.6 of the guidance. These are indicators that signify a particularly worrying, life-threatening situation, and that should therefore override the aggregated score to avoid severe needs being hidden by other indicators in the aggregation. You're now familiar with this template. So you can see that on the left-hand side, we have step 2, reconcile household and area level indicators. Then in the middle, you have the illustration of step 3, which is aggregate severity scores for all indicators for each household. And I'm now highlighting the step 4. Check if any critical indicator severity score is higher than the final humanitarian conditions score. So you would compare the result of the aggregated severity score, which is in column Z, with the critical indicator score, which is in column AC. In the example of line 2, we identified that the severity phase for this household was a phase 2. And we compare that with a critical indicator that gives us a phase 1. Because the calculated indicator is higher, we retain it. We don't need to override. The next step, step 5, is to estimate the percentage of households falling under each severity phase. The way to proceed is simply to calculate, out of the total number of households in the dataset, the proportion of households per humanitarian condition score. So for instance, in this table, for District A IDPs, we have a total population of IDPs of 10,000. And this specific population group is, the population is distributed across the 5 severity phase, with 16% of IDPs from District A falling into severity phase 1, 21% falling into severity phase 2, 27% in severity phase 3, 25% in severity phase 4, and 11% in severity phase 5. Switching to the scenario A aggregation tool again in Excel, you can see here how step 5 looks, and the simple estimation of the percentage of household falling under each severity class. Once you've got the percentage and the distribution of the population across the severity phases, the next step is to estimate the actual number of households falling under each severity phase. So to do that, it's quite straightforward. Multiply the percentages obtained in the previous step by the total population figures to obtain the corresponding number of people falling under each severity phase. Looking at the table here, let's take an example. So first line for District A IDPs, we have a total population of 10,000. We already have that information. And we look at severity phase 3. We knew that it was 27% of the population, and 27% of a total population of 10,000 is 2,700. Now, to obtain the total PiN, you just sum up the number of people that fall under severity phase 3, 4, and 5. This kind of concludes the aggregation method to obtain the preliminary PiN in scenario A. Just a couple of notes. The first one is that if probability sample data has been used for the aggregation, then the summary findings should be presented in conjunction with the estimated level of precision with which the findings can be generalized to the population. What we're talking about here is the confidence level and the error margin. The second note is that there's a key assumption here, if you look at the table, is that the household size is relatively homogeneous within each group in a given area, hence the percentage of households that could be projected directly onto the total number of indicators. It's not perfect, but it's good enough. So once again, switching to the scenario A aggregation tool to show you what step 6 looks like. So here in the middle, you can see the estimate of the number of households falling into each of the severity class. The next step is to review, interpret, and adjust those estimations as part of a joint analysis process. So please see section 2.4 in the JIAF 1.1 guidance for details on how to do this. I'll show you right now in the scenario A aggregation tool what it looks like. So here on the right-hand side, you can see that we've added a few columns to the table to show sector pins, assistance information, but also risk and projections on the table. The objective is that the JIAF team plus expert matters review the information and provide their best analysis on the HNO PIN estimate, which is then informed in column Y with a rationale documented in column Z. The last recommendation is that the final output table also flags any area and groups that are currently receiving assistance, as shown in the aggregation template just the slide before, so that you can ensure that the current severity phase is understood to be also dependent on the current level of assistance. The implication being that if current assistance would decrease, then conversely, the severity phase would likely increase. This now marks the end of the automated aggregation to produce estimated initial PIN calculation for scenario A. There are two key supporting documents for scenario A. The first one is a presentation on how the aggregation methods for the JIAF were developed. And the second is the scenario A aggregation template that provides template and a guide for the aggregation stage of the JIAF analysis that I've been demonstrating. So that's it for scenario A, quite straightforward in the end, and I wish you good luck with it. And now on to scenario B. So first let's have an overview of the steps. Also 8 steps, like in scenario A, but the process is actually quite different. The 0 step, so before actually starting the aggregation, is to obtain the household and area level datasets for all indicators that are included in your country's JIAF. Then you prepare the area level datasets, and in step 2, for each indicator and geographical area and affected group, calculate the percentage of people per severity class. Once you've got that, you estimate the severity class for each indicator. Then you aggregate all indicator severity phase scores within the humanitarian conditions pillar for each geographical area and affected group. Now you've got your severity phase score, you will check if any critical indicator severity score is higher than the final JIAF severity phase classification for a group or a geographical area. We'll see it more in detail, but if the critical indicator severity score is higher, then it can override the JIAF phase classification that is calculated. Then in step 6A, you estimate the minimum number of people that fall under each severity phase. To provide more disaggregated findings on top of the severity phase of the 25% most in need, you can use expert judgment to carefully identify the pockets of severe needs within areas. Much like scenario A, the final output table also needs to flag any area and groups that are currently receiving assistance to ensure that the current severity phase is understood to be as dependent on current level of assistance. And then finally, you review all of this, interpret and adjust this estimation as part of a joint analysis process. All right, let's get started on step 0. Like in scenario A, the step 0 for scenario B is to actually obtain the household and area level datasets for all indicators included in the country's JIAF. Once you've gotten hold of those datasets, prepare and clean them either using a data cleaning plan or guidelines similar to the Quartz Guide to Bad Data. Like in scenario A, don't forget to anonymize and/or sanitize the data sets so that no private information pertaining to any household could be made public. Finally, all original datasets, once they've been sanitized, should be uploaded on the Humanitarian Data Exchange platform for transparency purposes and to ensure reproducibility of the results. For each indicator, make sure that you document the cluster, attribute a number to the indicator, identify which subpillar it is nested into, provide the actual name and wording for the indicator, as well as its class. Is it a degree or is it a magnitude indicator? On that note, if you're not sure about magnitude and degree indicators, please go watch the video on indicator and severity. Then on column H, please inform whether this indicator is a critical one or not. Then you have the severity classes, and here you should inform the boundaries, the thresholds and ceilings for each severity class. Then slightly on the right-hand side, it's partly cut off, but you can check it out in the aggregation template or the data collection template. Please provide comments on how the indicators should be calculated if they're not used for the PiN. This is what a field indicator overview matrix looks like. Taking the example of some indicators in Afghanistan. And now let's get started on the aggregation process. So the very first step is to prepare the area level dataset. To build the JIAF dataset, all data should be summarized at the area level per population group and added into one dataset. Each indicator value should be recoded only to represent the severity score, so either 1, 2, 3, 4, or 5, and a common geographical field should be available for each area level indicator to facilitate the merging. Of note, for area level, it might be worth adding the unique ID or SSID of the camp or site along with the P codes if you have them. Now, one of the elements that created a few headaches in the implementation of JIAF 1.1 last year is the use of magnitude and degree indicators. First, some definitions. Magnitude refers to the number of people affected. On the other hand, intensity is the degree of severity. Because those terms are not always mutually exclusive, in the JIAF, we refer to indicators either at area level or household level. The distinction that is actually the most important is how thresholds are determined. If the threshold for an indicator is based on the proportion of people who fall into a specific group, then the indicator is magnitude-based regardless of how it was collected, even if it was collected through a household survey. On the other hand, degree-based indicators have household-leveled thresholds. Effectively, all degree-based indicators are collected at the household level, but not all indicators collected at the household level are degree-based. For example, the indicator looking at distance to the nearest health facility is based on threshold on how many people live more than 1 hour's walk from the nearest facility. Though this indicator is collected at the household level, the indicator is actually magnitude. More rarely, and this is where it gets actually quite tricky. There are a few indicators that are degree-based, so intensity, but are collected at facility or area level. For the moment, these indicators should be classified as magnitude because they can be more accurately aggregated that way. So this side note on magnitude and degree indicators is quite crucial to understand the aggregation methodology of scenario B. And it comes into play right now in step 2. So step 2 is that for each indicator, geographical area, and affected group, you should calculate the percentage of people per severity class. And this results in one area level aggregation dataset, including all household and area level data, but with unlinked indicators. Now, if you look at the last line, you see that there is something slightly different. For all area level indicators that by definition apply to the total population of an area, this means that 100% of the population will fall in a given severity class depending on the results of a given indicator. So on the last line, we're looking at distance to health facilities. This indicator can be looked up in the data aggregation template. And there you will see that the severity classes are as follow. So class 1 is more than 80% of the population has access to primary healthcare within 1 hour of walk from the dwellings. Severity phase 2 is between 75 and 80% of the population. Phase 3 is 70 to 75% of the population. Phase 4 is 65 to 70%. And finally, phase 5 is less than 60% of the population can access primary healthcare within 1 hour's walk from the dwellings. So that means that if more than 80% of the population can access healthcare within 1 hour's walk, then the severity of the area would be classified as 1. However, that does not mean that 100% of the population are severity class 1. It's actually not possible to calculate the exact degree-based severity for those households, but the proportion living under 1 hour walk from the health facility are still in need. For the present, while we look for a better long-term solution for incorporating area level indicators, we will use the provided calculated severity for magnitude indicators. Once again, provided by the sectors. And now a bit more information about what we mean by unlinked indicators. In data scenario B, either household level information is not available for all selected indicators, or different households have been interviewed across different assessments, and it would be impossible to discern if the same households were included in multiple assessments. This would be the case, for instance, if the JIAF analysis team was consolidating household data from a CAP survey conducted by WASH actors, an education assessment by education actors, a shelter damage assessment by shelter actors, etc. In this scenario, it is challenging to distinguish if the same people are facing issues in the 3 sectors or if they are simply different people with different issues. The households level indicators are thus unlinked, and the percentage of the population in the data that have co-occurring needs is unknown. This is the opposite of linked indicators in scenario A. All right, let's now get back to step 2 and what it looks like using the data aggregation tool. So we're on tab data entry, step 2, and you can see on the left-hand side the geodata. So the admin 1 admin 2, the P codes, and the population data coming from the CODs. Then I've put side to side 2 indicators to illustrate how magnitude and degree indicators are computed. So first, indicator 8. If you look into the data, the indicator overview tab of the aggregation tool, you'll see that indicator 8 is a degree indicator, and it's actually the percentage of households reporting marriage of daughters earlier than intended due to lack of food or income to buy food in the last 30 days. So as mentioned, it's a degree indicator, and so it allows for a graduation and disaggregation of the population per severity class. So we can see for Kabul on the first line that 99% of the population falls into severity class 1. And 1% of the population falls into severity class 4. Now, indicator 9 is a magnitude indicator. It means that it refers to the number of people who are affected. Let's say that it corresponds to the percentage of households unable to obtain seeds. In column AS, we're going to have the value of the indicator. So still looking at the first line for Kabul, the way to read it would be that 38% of the population are unable to obtain seeds. And this proportion of the population, 38%, corresponds to a severity phase 3. You might notice that the last column, the PiN, for indicator 9 is not informed here. So I just want to give you a side note. The template for magnitude-based indicators has some cells colored green and some blue. Variables in blue are optional, and this means that the sector only has to provide the value and severity for their indicator and details on thresholds. So that's for column AS and AT. The value and the severity for their indicators and details on thresholds. The PiN figure requested will be used to inform the maximum PiN figure across all indicators in the JIAF analysis. This figure helps to inform the expert judgment in the final calculation of PiN. If you choose to leave the PiN blank, then the indicator will still contribute to the severity calculation and thus to the base 25% that is provided as a starting point for PiN discussions, but it will not contribute to max PiN. We'll get into more details a little bit later. It will become clearer, hopefully. To calculate PiN, consider the values for your indicator and how they might translate into needs. For example, if there are 35% of households who are located more than 1 hour's walk from a health facility, and presuming the data was collected using reliable sampling methods, then it can be assumed that 35% of the area is in need. Thus, the PiN would be determined by multiplying the value, 35%, by the population of a group it pertains to. However, some magnitude-based indicators do not apply to the whole. For instance, measles vaccinations require a minimum of 90% coverage, well, up to 95% in urban areas. So if 28% of the sample group are not vaccinated, then the needs of that group are the difference between the actual, in this case 72% are vaccinated, and the desired, which is 90%. And it equates to 80% in need. It may help to think of those in need as those people who, in an ideal world, with every cent of required funding provided, would be targeted for assistance with programs that relate to that specific indicator. And now back to step 3. So once you've calculated the percentage of people per severity class for household indicators, and that you've identified the value proportion of people falling into the severity phase for magnitude indicators, then the step 3 is to estimate the severity class for each indicator. For each geographical area and population group, and each specific household level indicator in the data set, you can apply what we call the 25% rule. In the first line of the table, for instance, there are 11% of IDPs in District A who present a phase 5 severity on the water sources indicator. 11% is less than 25%, so the class defining threshold is not met yet. Going one cell left and adding the 75% cohort who present a phase 5 severity gives a cumulated percentage of population of 35%. So that's the 11% of phase 5 plus the 25% of phase 4 is equal to 36%, which actually meets the 25% rule. So the geographical area and population group is therefore classified as severity 4. Looking at the second line, we can reiterate this calculation. You start from class 5, which is 6%. Doesn't mean the 25% threshold. So you go one cell to the left, you add 11%. So that takes you to 17%. Still doesn't mean the 25% threshold. So you go one more cell to the left now into class 3, which is 37% of the population, and at the 17% plus 37% is equal to 74%. You pass the threshold of 75%, which means that you can attribute a severity 3 to this indicator. Now, for area or magnitude-based indicators here, the outline thresholds will allow their values to be converted into a severity classification for each geographical area. So if you look at the last line, you see that the severity class was already informed, and we had a severity 1, and so it is attributed to that indicator anyway. But in other words, if the severity phase is 2 or above, then the minimum population in that severity phase or higher is 25%. If the severity phase is 1, then we assume that a minimum of 75% of the population is classified under severity 1, as the combined needs of all other severity levels is assumed to be less than 25%. A little side note here on the 25% rule. 25% was selected after testing thresholds for 10%, 15%, 20, 25, and 30% on 10,000 simulated data sets with different distribution, uniform distribution, normal distribution, Poisson distribution, etc. The 25% threshold was the most likely to yield the same final results as the one obtained from the scenario A aggregation method, and that would be they would be the same in 83% of the 10,000 comparison. This demonstrates that scenario B proposed aggregation method is able to estimate to some extent the co-occurrence of needs. But for further detail on the aggregation method, please look at the key resources at the end of the presentation. Just for reference purposes, this is in the data aggregation tool template, and the tab is step 4, the long data. And now on to step 4, which is to aggregate all indicator severity phase scores within the humanitarian condition pillar for each geographical area and affected group. The recommendation for the aggregation method here is the mean of max 50% of indicators, if there are more than 4 indicators, which is the majority of the time, and then simply the mean if there are less than 4 indicators. For each area, the mean of max 50% returns the mean of the indicators that have the highest scores, focusing only on 50% of indicators that have the highest scores. As a side note, this comes from testing the aggregation methods, where it was concluded that the arithmetic and geometric mean, median, and weighted sum all suffer from central tendency, meaning that overall severity scores are pulled down the more indicators are introduced. In reality, it means that a household may then have very severe needs outcomes on some indicators, but will not be identified as severely in need if it happens that they have low severity scores on some indicators. The probability of this happening increases with the number of indicators that are available. So if you think that in the indicator reference table, we have 123 indicators, including 97 on the humanitarian conditions, this is a real risk. Although, to be honest, I don't think I've seen a JIAF with more than 40 indicators in the humanitarian conditions pillar, but 40 indicators would still trigger that central tendency. So this situation can be avoided by applying the mean median using only the most severe indicators in each household. As long as an absolute scale has been used for all indicators, this should give an accurate estimation of the overall severity faced by the household. So this is what it looks like in the aggregation template. We're on the tab for step 5, severity. And you can see on line 2 that I've highlighted the indicators, numbers. And on cell AN2, you can see that the column is titled the mean of max 50% of indicators, here of 34 indicators. So what you see here are the 50% highest indicators for Kabul. The formula is displayed also on the screen. And in cell AN4, we have the mean, so the average, of those 50% of the max indicators. So what it means is that we took the 17 highest indicators for Kabul and averaged the severity for those highest 17 indicators, and the result was 2.1. Everything between 2 and 3 is actually falling within the class 2. Once you've got your calculated severity, the next step is to check if any critical indicator severity score is higher than your JIAF calculated severity phase classification for a group or a geographical area. If that's the case, you can override the score with the critical indicator score. For more information on critical indicators, I would suggest that you watch the the session on indicators and severity, and specifically the slide 23 and 24. But in a nutshell, the critical indicators were identified earlier in the JIAF process, and these indicators signify a particularly worrying, life-threatening situation, and that should therefore override the aggregated score to avoid severe needs being hidden by other indicators in the aggregation. So now going back to our aggregation templates, you can see in column AN our calculated severity score using the JIAF methodology. And then in column AO, you have in purple one critical indicator, which is the IPC. If an IPC is available, the IPC is always a critical indicator. So looking at line 1 for Kabul, we see that the calculated JIAF severity in column AN is 2. And if you look at the IPC, the severity for the IPC in Kabul is 3. So what it means is that the IPC severity is higher than the JIAF calculated severity. And so what we're going to do is to override the calculated severity with the critical indicator value. So in column AP, we have a severity corrected for critical max, and it's rounded up. So you can see here in column AP that for Kabul, we now have a final severity phase of 3. Now that you've got a severity phase, the next step is to look at numbers. So estimate the minimum number of people that fall under each severity phase. Since the 25% rule was used to obtain the area/affected group severity phase, and the combination of 25% rule and the mean of max aggregation method was found to relatively accurately predict co-occurring indicators, 25% can be multiplied by the total population figures to estimate the minimal number of people that fall in the severity phase or higher. For instance, for IDPs in District A in this table, where the total population is 10,000, the calculation would be 25% times 10,000 equal to 2,500. And for the residents in District A, it would be 50,000 times 25% equals 12,500, etc., etc. In other words, 1. If the severity phase is 2 or above, the minimum population in that severity phase or higher is 25%. And 2, if the severity phase is 1, then we assume that a minimum of 75% of the population is classified under severity 1, as the combined needs of all other severity levels is assumed to be less than 25%. So you now have a minimum number of people falling under each severity phase, but you can go a little bit deeper in the analysis and provide more disaggregated findings on top of a severity phase of 25% most in need by carefully identifying pockets of severe needs within areas. You can use other information, such as the maximum PiN across indicators, to review your calculated PiN estimate and use expert judgment to finalize your PiN, and it will become the HNO PiN estimate. A little side note here on critical indicators in PiN. While critical indicators can be used as a single source to derive and override the intersectoral severity, the same is not true for the definition of intersectoral PIN. In fact, the PIN would be defined based on expert judgment, taking into account not only the critical indicators, but a wider array of sectoral indicators. As a result, the intersectoral PIN should not be lower than the value of critical indicators in any given area, but could be higher. And now looking at the table in the aggregation template. So we're on the tab for step 6, the PIN, and you can see columns I and J are being highlighted. And so column I is the minimum number of population in this severity class or higher. And you have the JIAF PIN estimate based on the calculations. Now you're almost there. In step 7, the final output table also needs to flag any area and groups that are currently receiving assistance to ensure that the current severity phase is understood to be dependent on the current level of assistance. The implication being that if the current assistance were to decrease, then conversely, the severity phase would likely increase. So this marks the end of the automated aggregation to produce an estimated initial PIN calculation. And the next phase is actually to apply expert judgment and finalize the estimation. In other words, step 8 is to review, interpret, and adjust the estimations as part of a joint analysis process. To encourage country teams to conduct this joint analysis and finalize the estimation of a PIN, we've kind of hard-coded it into the data aggregation tool. So if you go into step 6, PIN, what you see is the calculated initial PIN estimate in column J, and then we've added a few additional information that could be considered and should be considered when you finalize your PIN. So as an example, what we've added here is the max PIN across all indicators in column K. But you could also look at the max sector PIN. So that's the max per cluster. It's in column L. In this table, it's actually empty because we've left that data empty in the model. But if information is collected, it should be reflected here. In column M, we have IDP groups. We also have returnees and populations that are prone to natural disaster, living in natural disaster areas, etc., etc. You could add whichever indicator is relevant for your country. And those indicators could help you review the JIAF estimated PIN, and through expert judgment, you could agree to change that figure, and then you reflect it in column T. If you do change the figure, it would be great to document it. The last tab of the aggregation template is actually a PIN overview of the PIN per indicators. And you can see, because it's highlighted in orange, which are the indicators with the highest number of people in need per area. So in this specific example, which, kind of using partly fake, partly original data, you can clearly see that there is one indicator that clearly shows highest number of people in need across the geographical areas. This is, of course, indicator 6 here. So percentage of school-age children enrolled in school prior to COVID-19 without access to education in a safe and protected environment, where protected environment is defined as available hand washing facilities and heating. So this would be the indicator with the highest number of people in need across the entire country. But you can see other hotspots in other sectors. There's the one in orange and circled, squared in red here. This table is just to give you an overview and additional information that can be used in the expert judgment sessions to support the intersectoral analysis. It helps you to see the outliers. So this concludes the aggregation methodology for scenario B. The key document and supporting tools that you should look at are the aggregation method for the JIAF, which is a presentation on how the aggregation methods were developed. And the two templates that I've presented throughout this session, which is the data collection template and the aggregation template. Finally, a few links to consider as well. On the JIAF and the HPC, you have here the link to the facilitation package, which includes the JIAF 1.1 guidance. There is also a bit more on the methodology. So you have a link here to the JIAF indicator reference table, as well as the indicators for the context, shock, impact pillars, which are in Annex 3 of the JIAF guidance. You could also look at the testing aggregation method that was developed by Rich if you want to go into the nitty-gritty of the methodology and the statistics of it all. Finally, two more pieces of information. If you're encountering some difficulties at the country level, we suggest that you reach out to your global counterpart. So if you're an intercluster coordinator, please reach out to your counterpart in OCHA. If you're a national cluster coordinator, reach out to your global cluster coordinator. And if there are some difficulties in or conflicting views on interpreting the guidance, you can send an email to the JIAF help desk at jiafhelpdesk@gmail.com. This is an interagency platform with representative of the various clusters and OCHA that will get back to you with a coordinated, agreed answers. Finally, you can find additional information and resources on the JIAF website, which you can see at jiaf.info. Finally, a few more links to share with you. So beyond the JIAF 1.1 other trainings, I would suggest that you have a look at the other documents that are part of the HPC facilitation package, with, of course, a special focus on the JIAF 1.1 guidance. In terms of technical methodology, three things. First, the JIAF indicator reference table. That combines all the different indicators for the humanitarian conditions. and a few for the impact pillar. Would also recommend to look at the indicators that were compiled for the context, shock, and impact pillars that are part of the Annex 3 of the JIAF 1.1 guidance. And if you want to dig a little bit deeper on the aggregation, I would suggest to look at the PowerPoint prepared by Reach that goes through the various testing aggregation methods that were researched and that have yielded the current aggregation methodologies. Finally, I want to share two other pieces of information. The first one is that should you encounter difficulties in terms of interpretation of the guidance, and those can't be solved at the country level, you can reach out to the JIAF help desk using the generic email address jiafhelpdesk@gmail.com. And it will go to our help desk. It's a platform composed of representative of the global clusters and OCHA, and we will get together and review your query and get back to you in a concerted manner. Finally, please feel free to visit the JIAF website at the address jiaf.info, and we'll be posting updated resources, trainings, etc. there. This concludes our in-depth session on the aggregation methods and PiN. I really hope you enjoyed it and that it was useful, and good luck.